My name is Syed Hussain Shah. I'm doctoral candidate at TU Munich and working under the supervision of Professor Amde Bowman and Professor Frank Pitzel. Well, a typical research activity, okay. So a typical research activity starts with planning and design. When the planning and design phase is done, data collection and creation process start. During these activities, researchers analyze and collaborate with partners within the group and outside of the group, regardless of boundaries. However, these processes also require to properly manage and store all the related data. When a particular milestone is achieved, then the results and data are shared and published in a way that they are discoverable, citable, and reusable. Therefore, research data management activities relate to storage, organization, documentation, and dissemination of research data. The activity of data management and publishing are usually guided by FAIR principles. The FAIR principles provide guidelines about 4 foundational principles. Those are findability, accessibility, interoperability, and reusability of data, and the information that led to that data to guide data producers and publishers. Different stakeholders, for example, funding agencies like German Research Foundation, publishing houses, so on and so forth, require researchers to exhibit good research data management during the whole life cycle of the research project, so that the results are transparent, reproducible, and reusable. To perform research data and comply with the requirements, a range of tools and comprehensive system is required. In this paper, present the case of Research Data Management of Collaborative Research Center, Transregio 277 Additive Manufacturing and Construction, in short AMC. It is hosted by Technical University of Munich and Technical University of Braunschweig. There are 3 focus areas: materials and processes, computational modeling and control, and design and construction. Its research community comprises of more than 120 members and divided into 22 interdisciplinary research groups stationed at various locations. The research data being generated in AMC ranges from field survey, laboratory experiments, simulation to software code and hardware design, etc. Therefore, the data being generated in this project is big, broad, and heterogeneous. During research, data evolves and go through different stages and processes. For example, from raw data to processed data and to data as product. So it could have different versions based on versioning techniques, and different applications are being designed around different versioning techniques. And services and systems are also being formed to manage research data. These systems can broadly be categorized in 4 main categories based on their functions during research data management activities. Those categories are storage systems, development support systems, publication platforms and repositories, and virtual research environment. Due to collaborative nature of research at AMC, TUM Workbench is being employed as VRE. Apart from general data management tools, TUM Workbench also offers data management plan templates and their management. Data management plans, in short DMP, are one of the important tools of research data management. DMPs are considered as key element of good data management. DMP contains information about the handling of data when it goes through different processes. It consists of questions relating to the data, its handling and dissemination. The process of DMP authorship starts with explanation that how the data will be generated, managed during the proposed research work. However, once the research starts, DMP turns into a document that needs to be updated by documenting the ongoing practices. Currently, it's a free text form, no standard, no set procedure, no specific guidelines. For example, when, what, and how to update. Study of 813 data management plans shows that only 7% could be considered as an attempt of good effort, and only 36% contains complete sentences. Recently, new approaches are being suggested by the research community, for example, Research Data Alliance, to make it as machine actionable data management plans. In this research, a strategy is being defined to make a dynamic plan so that the task of data management plan could be done semi-automatically. The approach is being supported by defining research data management system and practices on one hand, on the other hand, by defining modules and models for DMP. For example, in AMC, metadata could be managed by managing context of the data. The context management could be aided by higher level data classification, for example, code data publication and resources. Then a DMP should be integrated form which could communicate and consume information from and to the metadata layer of the data. As a result of the management of data and its context, metadata entries of a data file could be basic information, for example, who did and when the data got changed. The contextual information example could be that to which project and activity data belongs, what caused the new version of the data, and the log of data revisions. And if this information is guided with data lifecycle model, an automation of the DMP could be conceived. For example, when data goes through different user domains and when different operations and processes are performed over data, metadata logs could be updated with respective information. So as a result, a system to dynamically update data management plans evolves. In the proposed design, system consists of data together with its metadata part, profiler, data management plan component consisting of forms and its control elements. Since the data has an associated metadata part, a profiler component will serve two purposes. One, to iterate through the data and corresponding metadata to create a glossary. Second is to fill the missing metadata fields of the corresponding data automatically or suggest user in case user attempt it manually. Data management plan component represents DMP form, including its data model as well as its controls. DMP controls will be communicating with the metadata part of the associated data to consume or suggest user for input in the plan. If the information is missing on the data part, then DMP user as well as data part, for example, data manager, data system could be informed. DMP component will also have an associated context, which will be governing contextual information and states of DMP. Data model resolver will be resolving DMP form, data model, etc. as per corresponding data set. User interface control engine will be dynamically resolving form and user interface components rendering at the runtime. So as a future work, the definition of data model of the DMP template is in process. When the model is ready, the implementation will be started. In the meanwhile, further AMC specific research data management use cases will also be investigated and identified. The development of workbench is a kind of continuous process. Therefore, the definition and implementation of the new features will also be continued. The investigation and development process is aligned with design science research methodology. Thus, last but not least, the evaluation process will also be done in future. Yeah. Thanks for your attention. Yeah.
Thank you.